All right, welcome back. Today we're going to talk about linear regression. Linear regression is a method that will actually help you come up with lines when you don't have any lines. So here's some set of data, and what you really have is just some points. Okay, now this is in months, and before we can plot anything, we need to change that to numbers. So we're going to just use the numbers 1, 2, 3, etc. And remember, this is x and y, so we have to plot on an xy coordinate plane. So we're going to use x as months and y as income. So over here, we're going to start labeling them. We got 1, 2, 3, 4, 5, 6. And then up on this one, let's count by tens, 10, 20, 30, 40, 50, 60, 70. And we have at 1, we're at 40, so 10, 20, 30, 40. And then at 2, we're at 45 and 51. And so on. And the point is we want to develop a line that would fit all this data. Now, it's not going to be perfect, but we can get something that's pretty close. And we call this the line of best fit. So if we graphed a line that goes right through here, through most of your data, this is called the line of best fit. And that's what that's what linear regression comes up with, is the line of best fit. And the other thing it's going to tell you is the correlation coefficient. Okay? So before we talk about correlation coefficient, let's go and figure out how to come up with this line. So we're going to take this line. We're actually going to learn how to use the calculator. So I'm going to get the calculator out. And let me see if I can make it a little bit smaller so we can fit in here. There we go. All right. So normally we've used Scratchpad. In this case, we're going to actually add a new document, and we're going to add number 4. So when you start on it, let's close this out so you can see it. You're going to click over here on number 1, new document. So don't use Scratchpad. Use 1, new document. And we're going to add number 4, a list in a spreadsheet. And it should look something like this. Now the things that you have is this top row right here. This is your labels. The second row is for formulas. We're not going to use it, so leave this row blank. And then this is where we put all of our data down here. So you can use the keypad, and center is a mouse pad, so either way. But you need to get up here, and we're going to label it. You can label anything you want. I'm going to label mine X, just because we labeled it on X and Y. And then we're going to label this one Y. Okay, so remember the second row stays blank, so now we got to put in our data. So here we're going to put in the numbers 1 through 6. Okay, and then we're going to go up to the second column. Make sure you start back at the top. And we're going to put in our other numbers, which we got 40, 45, 51, 57, 61, and 65. And feel free to pause this at any time if you're not being able to keep up, because it's really important you learn how to do this with your calculator. So we got all of our data in here. We have it labeled X and Y. We have nothing in the second column. The next thing you need to do is you need to find up one of these empty squares. Now, don't use the top 2 rows. Those are reserved. But anything that else is empty. You don't want to use one of your existing squares, because what it's going to do is erase your data. So pick one of these empty squares like this. It needs to be blue. So if it's like this where you got the mouse pad, click on something else. It has to be a blue square. And you're going to go to menu. And it'll pull up this table. And we want number 4 statistics. And then you want number 1 stat calculations. Okay, so I'm going to do that again. Menu, 4 is statistics, and 1 is stat calculations, and it brings up this menu right here. And we want a linear regression. Now there's 2 of them to pick. We're familiar with mx plus b, so we're going to pick number 3, linear regression mx plus b. Now what this menu is telling you is they want to know, what did you call these lists. So our first list, we called it x. So we're going to just type in x. The second list we called y. Now if you called it something else, make sure you list these. We're going to go ahead and leave the rest of these blank, and I want you to arrow all the way down. You can enter all the way through to get to this OK, and click on that OK. And what it should have done is put in a whole bunch of data over here on the right hand side. Okay, so we have a title. Don't worry about that. If you forgot mx plus b, it's written here for you. And then it tells you what m is, and it tells you what b is. So we should be able to write our equation now. So we're going to go ahead and write this equation. Our equation is going to be y equals 5.1x plus 35.2. So let me make this a little smaller so that we can start writing over here again. Okay, so it's going to be y is equal to 5.11x plus 35.27. We're going to round. Don't just stop writing. We're going to round. And then this last number we need is the r value. So that's r squared. So let's scroll down just a little bit. And here's the r. And our r is 0.997. So we need to write that down. R is 0.997. Come on. There we go. So R is 0.997. Okay, so we have everything I need. We have the equation. So this line right here is y equals 5.11x plus 35.27. And the last thing that we're looking at is this r value. This is our correlation coefficient. What it does is it says how perfect are these dots. Now, if it was 100% perfect, the dots would be right on this line, and we would call that a correlation of 100%, which in decimal form is a 1. Now, we could have a negative slope, in which case we'd have a negative 1. So the negative sign you may see sometimes is just talking about the slope. Positive slope being a positive number, negative slope being a negative number. What we're looking at is the number itself. We want it to be close to 1. This one is 0.997, which is really, really close to 1. It's kind of like 99.7%. Because when you change the decimal to a fraction or a percent, you move the decimal point over 2. So it's 99.7%. This is considered good. This is a good approximation line. So anything over 0.9, so anything bigger than 0.9, or on the other one, it'd be negative 0.9 or less. Okay, so anything above 0.9 or less than negative 0.9, so it's between 0.9 and 1, or between negative 0.9 and negative 1. That's what we're looking for. Those are considered good lines. If you're somewhere in this 0.7 to 0.9 range, we're going to call this so-so. And anything worse than a 0.7 is pretty bad. So this is a really good line, so we have a lot of confidence in it. Now we're going to use it to predict the future. So let's say that I know these months, and I want to know now for October. So first off, we need to know what month is October. And if we keep going through the pattern, you'll know that October is the 10th month. So what that is saying is that we're going to plug in this 10 right here is x, so we're going to take it and plug it right here into our equation where this x is. So where it used to be, we're now going to solve it. So we got y equals 5.11 times x, which is 10, plus 35.27. And we want to go ahead and do that arithmetic really carefully. So multiplying that out, we get 51.1 plus 35.27. And what do we get? 5, 6, 7, 8, 6.37. So according to our prediction, in October, we should expect to see about $86.37. So is it exactly accurate? No, but we have a great deal of confidence because our R value, our correlation coefficient, was very high. So if you have any questions, make sure you ask. But this is how you use your calculator right here to perform a linear regression. Find the line of best fit, which is what we did right here, and then look at the correlation coefficient to make a prediction for the future. And that's what we're going to ask you to be doing. So if you have any questions, please make sure you ask.